This is Unit 6, Lesson 5. In this lesson, we're going to learn about synthetic division, which is just another tool to break down in our bigger polynomials. And the ultimate goal for learning our synthetic and long division so that we can factor the cubics and the quartics that can't use our factoring patterns, and so that we can solve them as well. Because we want to at least break it down into a quadratic, an x squared, so that we can use those techniques to continue the solving process, okay? So synthetic division is kind of the shorthand to long division. It's a little bit quicker, it's a little bit neater, but it won't work in every situation, so we do need to be able to do both synthetic and long, okay? And I'll talk about a little bit just when it's good to use it and when it's better to use long division. All right, so for synthetic division, believe it or not, we're actually not doing too much division in it. It's just another way to set it up. So you can see the steps are written up here, and I'm kind of just going to like talk through them as we go through the first example. But there's some similarities with long division. First of all, when we're doing this, we need to have every term represented. So if there is a missing term, please make sure that you fill it in with a coefficient of 0. Okay, so it says that right here. Be sure to account for any missing terms. So we're not going to set up a typical division bar. We're going to set up an upside down bar. And there's different ways to show this, to set it up. So if you work with someone that kind of shows you the setup in a different method, that's totally fine. The steps are identical. It's just kind of where you're drawing things or whatever. All right, so what we're going to do is we're kind of compressing it. We're not going to include the variables in our work. So the first thing we want to do is take our divisor, and like long division, that went on the outside, but we're not going to put the x plus 1. We actually want to put the 0. So if we think of the x plus 1 as potentially a factor, we want to put it equal to 0 and solve. So what I'm going to divide by is the opposite. I'm going to divide by a -1. So that's one difference between long division and something you need to keep track of. And then inside the box or the bar, or whatever we want to call it, we're going to put the coefficients of the polynomial. So I'm going to put 3, 5, and 2. And here's where you would have to account for any missing terms. So since I have an x squared, an x, and a constant, I'm good. Nothing is missing. Okay, so now it's set up, so now I'm just going to go through the process. So the first thing we're going to do is we're going to bring down this first term. Okay, and then I'm going to multiply. I'm going to take this 3 that I just brought down, multiply it by the -1, and put that over here, -3. And then I'm going to add. So you can really think about, you kind of added this first column here if you put a 0 to begin with, but you don't need to think of it that way if you don't want to. So I add and I get 2. And then I'm going to multiply 2 times the -1. And I put a -2. And then I'm going to add and I get 0. All right, so that's the compressed version. So we need to expand it and put our variables back in. So you always start for number furthest to the right. The number on the right is always your remainder. So in this case, it's a 0. So I don't have a remainder. The number next to that is your constant. So that's a 2. The number to the left of that is my linear term. So that's a 3x. If I had another number to the left of that, that would be my x squared. If I had another, it would be my x cubed. Okay, so for this one, we're kind of starting at the right and identifying what it is. You're always going to have a number here for a remainder, but that number may be 0. In this case, it is, so we don't have to write that. All right, but just so you know, that's your remainder. So my answer is 3x plus 2. And if you went through and did the long division, you should get the same thing. Okay, let's take a look at another example. So this time, what we're dividing by is going to be a +1. So I put that up top. I draw my box. Now look at the dividend. What I'm dividing is missing a term. I don't have an x term. So when I plug it in, I need to put a 0 in place of it. So that's super key. And that's something you also need when you do the long division. So I've got 3, 0, 5. Okay, so start by bringing that 3 down. Okay, doing 3 plus a 0, not that you need to write that. Now I multiply, 3 times 1 is 3. Add straight down, giving me 3 down here. 3 times 1 is 3. Add straight down and I have 8. Okay, and I'm done because there's nothing else to, no other numbers to work with. So this 8 is my remainder. That's my constant, and here's my linear, my x term. So it's going to be 3x, sorry, I was writing an 8, plus 3. Remainder we write the same way we do with long division. Write it with the original dividend. So it'll be 8 over x minus, sorry, the divisor, 8 over x minus 1. Okay, so this is my answer. All right, our next example, Same concept. If you want to try this one on your own, pause the video. I'm going to talk through it, but if you want to give it a try and see what you can do, pause it and then come back and check. All right, so I'm going to divide or put -5. And then I have 1, 4, -5, -9. Bring down the 1, multiply, -5. Add, giving me -1. Multiply, giving me +5. Add, giving me 0. Multiply, I get 0. Add, I get -9. All right, so the -9 is my remainder. This is my constant. Here's my x term, and here's my x squared. So it's x squared minus x. I don't need to write plus 0. That's implied over a -9, x plus 5. Okay, so as you get the hang of this, it's definitely quicker than long division. So why didn't we just do this from the start? There are cases where it's not going to work. You have to divide by a linear component. So in one of our examples in the long division, we were dividing by a quadratic. It was x squared plus x plus 2 or something along those lines. The synthetic division won't work for that. So in that case, you have to do long division. So you cannot be dividing by anything that has a term greater than a linear term. In addition to that, you cannot divide, oops, sorry, I didn't mean right over it, but you have to be careful if the coefficient of your linear term is not 1. All right, I've got 2x plus 5 in this one, so I have to take care of that. So just like before, we said put it equal to 0 and solve. So I'm dividing by -5/2. So when that coefficient of your x term is greater than 1, you've got to be careful. You've got to account for that when you're doing your division. We also are going to have to account for that at the end. So that's why synthetic division is best for when you're dividing by a linear where the coefficient is 1. So kind of like in completing the square, we could do it for other ones, but it could get messy. Same thing here. So when I go and divide, I've got -5/2. I have 8, 36, 46, and 15. So I'm going to do the same thing. Bring down my 8. When I multiply -5/2 by 8, I get -20. Add, which gives me 16. Multiply, which gives me -40. Add, which gives me 6. Multiply, which gives me -15. Add, which gives me 0. Okay, so I've got a remainder of 0. Now, before I write it out, when you were doing the synthetic division and your original divisor had a coefficient greater than 1, you have to then go through and take this denominator and divide everything down here by 2 except the remainder. So if I had a remainder of 1, I would leave it as 1. I'm not going to divide that. So when I divide this by 2, divide this by 2, and divide this by 2. So my final answer is 4x squared plus 8x plus 3. Okay, so you can do the synthetic division if you have a coefficient in front of 1. You just have to be super careful. We have to account for that when we're coming up with what we're dividing by, and you'll have to count for that denominator again at the end, a step that sometimes we can tend to forget. So I recommend doing long division when you are dividing by a linear term that has a coefficient greater than 1. And you have to do long division if you're dividing by anything greater than a linear. All right, so we have one more example. Once again, if you want to try this one on your own, pause the video. All right, so I put this equal to 0. I solve, and I'm dividing by -1/2. So put that on the outside. I've got 6. All my terms are present, so -13, -12, +4. Break down the 6. I multiply, and I get -3. Add, -16. Multiply, 8. Add, -4. Multiply, 2. Add, 6. Okay, so once again, because I had a divisor here, I need to divide everything by the 2, except the remainder. So we have 3x squared minus 8x minus 2, and then plus 6 over 2x plus 1, because that was the original divisor up here. All right, so synthetic division definitely can be quick. It's definitely a good tool. We're going to take a look at some theorems down below. So it'll help us break down polynomials. And this also helps us determine if something is a factor. If you think back to the long division notes, we had talked about, if we divide by something and then we come out with no remainder, what does it mean? It means that that's a factor. So same thing here. If I'm asking you, hey, is 3x minus 2 a factor of this polynomial? As opposed to going through and trying to factor that by hand, you might also not be able to do it by hand. You can use synthetic division to check. How do I know if it's a factor or not? It's a factor if the remainder is 0. Okay, so sometimes we're going to have polynomials that you can't use your basic factoring techniques, so we can do the synthetic division to break it down, okay? Or long division, either way, really. But at the end of the day, if the remainder is 0, it means it was divisible evenly by that polynomial, so it is a factor. The other thing that we can talk about is our remainder theorem. So it tells us if a polynomial is divided by a factor or another polynomial, then the remainder is equal to the original function. So what that's saying is it really just another way to evaluate functions. If I take this -2 and I do synthetic division, the remainder is the output, meaning if okay, so back in Algebra 1, you learn just substitute -2 in and do math, and whatever you get is your output. Okay, that would be a point on this function. Well, we can also do that with synthetic division. So I'm giving you -2, that's the 0, so that's what goes on the outside. And if we fill in 1, -3, 2, and -1, go through our synthetic division, bring down the 1, multiply, add, multiply, add, multiply, add. -25. That's the remainder, that's the answer. Meaning, if I substituted -2 back into the original function, this is what I would get out of it. So just understanding that relationship, that synthetic division can help you do that. All right, so that tells us that, if I put that as a factor x plus 2, right, because that's the opposite of -2, is not a factor of the original problem because I have a remainder, but I can use it to evaluate. It's just another evaluating tool as well. All right, and that's all there is to synthetic division. So if you weren't in class, make sure you pop online and get the practice so that you can practice this concept. Adios.